Let's talk about how to find the domain of a composite function. Let's take this example. F of x is x plus 3 over 2x minus 1, and g of x is 3x over x plus 5. And let's find the domain of f of g of x. The way you compute the value of f of g of x when you plug a number in, let's plug in 3. To compute f of g of x, you first plug a 3 into the function g of x. And what is g of 3? Well, that's going to be 3 times 3 over 3 plus 5, which is 9 over 8. So the number 9 over 8 comes out of the function g, and then it goes into the function f. And what is f of 9 over 8? Well, that's 9 over 8 plus 3 over 2 times 9 over 8 minus 1. And let's see, what is that? That's 33 over 8 if you get common denominators, over, let's see, that's going to be 9/4 minus 1, which is 5/4. So that's going to be 33 over 8 times 4 over 5. And we can cancel the 4 into the 8, and we get 33 over 10. So out of f comes a 33 over 10. So when we find f of g of 3, we get 33 over 10. And we're thinking of this as an assembly line. These functions g and f are just machines on this assembly line. The 3 goes into the function g, and out comes a 9 over 8, which goes into the function f, and out comes 33 over 10. So when you're looking for the domain of a function, I want you to think about the way composite functions work. And they act kind of like an assembly line. Okay, so let's find the domain of f of g of x. So let me erase some of this. And again, let's think of this as an assembly line. We're going to plug a number into the function g. Out of that comes some other number, and that goes into the function x, f of x. Okay, so what can we plug into the function g? Well, we can plug in any number into the function g. Look at that. Any number except a -5. Why is that? Because we can't divide by 0. To find the domain of g, what we have to do is set that denominator equal to 0. And when you solve that for x, you get x as a -5. Which means if you plug a -5 into the function g, you're going to get a -15 over 0, which is undefined. Okay, so we cannot plug a -5 into g. Okay, so x cannot be a -5. We could plug any other number into g. But whatever comes out of g goes into the function f. And what's the restriction on f? What number can we not plug into f without dividing by 0? Well, look at the function f. To find its domain, we have to set the denominator equal to 0 to find out what number is going to cause us to divide by 0. So we set 2x minus 1 equal to 0, and we solve that for x, and we get x equals 1/2. Which means if we plug a 1/2 into the function f, watch what happens. We get 1/2 plus 3 over 2 times 1/2 minus 1, which is 3.5 over 0. Again, that's not allowed. Cannot divide by 0. So whatever number is coming out of G cannot equal, this cannot equal 1/2. So the question is, what number do we plug into the function G which is going to cause a 1/2 to come out? Well, let's figure that out. So I'm going to set the function G equal to 1/2. And we're going to figure out what number can I plug into the function G that's going to cause an output of 1/2. Well, we can cross multiply because this is a proportion. So 3x times 2 is 6x, and 1 times x plus 5 is x plus 5. You subtract x from both sides and you get 5x equals 5. And so x equals 1. Which means if you plug a 1 into the function G, it's going to output a 1/2. Let's try that out. G of 1 is going to be 3 times 1 over 1 plus 5, which is 3/6, which is 1/2. And we know we cannot plug a 1/2 into the function f. So we're not allowed to plug a 1 into the function G. And we're done, because now we know what we're not allowed to plug into G. So the domain of f of g of x is a set of all numbers such that x is not equal to 1 and x is not equal to a negative 5. Okay, next let's find the domain of g of f of x. Okay, so if we're looking for the domain of g of f of x, we have to see what numbers, when we plug them into this function f of x, are going to cause a problem in this machine f. And if something gets by this machine f and goes into the function g, whoops, hold on, goes into the function g, what numbers are going to cause a problem there? Well, first of all, let's look at this f of x. What numbers are we not allowed to plug into f of x? Well, again, to do that, we set the denominator of f of x equal to 0. And if you solve that equation, you get x equals 1/2. Which means we cannot plug a 1/2 into f of x. But now the question is, whatever comes out of f of x is going into g of x, and that cannot cause g of x to divide by 0. If you look at the function g of x, what number can we not plug into the g of x? Well, if you set the denominator of g of x equal to 0 and solve it, you get x as a -5. So whatever comes out of f of x cannot be a -5. So we have to figure out what number, when we plug it into f of x, causes an output of -5. So to do that, we're going to set x plus 3 over 2x minus 1, that's f of x, equal to a -5. And again, this is a proportion, and we solve it by cross multiplying. -5 times 2x minus 1 is a -10x plus 5. And 1 times x plus 3 is x plus 3. If you add 10x to both sides and subtract 3 from both sides, you get 2 equals 11x. So x is going to be 2 over 11. Which means we're not allowed to plug a 2 over 11 into the function f. So x cannot be 2 over 11, because if we do plug in 2 over 11 into f of x, f of 2 over 11 is going to be a -5, and we can't allow that to go into the function g of x. So the domain of g of f of x is going to be every number except 2 over 11 and 1/2. The domain of g of f of x is a set of all numbers such that x is not equal to 1/2 and x is not equal to 2 over 11.